Okay, students, let's talk about how we add vectors that are not perpendicular. If we just add vectors that are perpendicular, if there's an x and a y component only and they're at right angles to one another, then Pythagorean theorem and the inverse tangent is all that we need. However, we've got a few steps if we have vectors that are not perpendicular to one another. And you can do this for any number of vectors that you're adding. It doesn't have to be just 2, it could be 3, 4, or as many as you have. So the first thing you want to do is you want to resolve each of the vectors into its x and y components. So sometimes the vector is along an x-axis or a y-axis, in which case there only is an x and a y component. But if it's not, if it's at some other angle, then it's going to be in your best interest to draw a separate triangle for each of those vectors, and then use that triangle to find the x and the y components. Once you have that done, and you have all your x and y components, you want to add up all the x components to find the x component of the resultant, and then do the same thing for the y components. Add up all the y components for each of those vectors, and that will give you the y component for the resultant. Now, be very careful, because when you're drawing those triangles, those separate triangles for each of the vectors, some of those components might be in the positive direction, some might be in the negative direction. So it's important that you do that. Once you have the x and the y components, you essentially have a right triangle at this point. So you can use Pythagorean theorem to find the magnitude of the resultant vector. And then you can use your inverse tangent using the x and the y components to find the direction of this new resultant vector. So these problems, if you break them down into separate steps like this, into separate triangles, then you already have all the tools that you need. You don't need any other fancy trig to do this. You can just use your Pythagorean theorem, and you can use the basic trig functions. They sometimes can take up a lot of space on your paper. It doesn't necessarily mean they're more challenging to do. So I'm going to put a practice problem up on the screen, and then we'll walk through how to find the answer to that particular problem. Let's take a look. Okay, so we have this problem, and this problem says that we have a plane, and the plane travels 118 kilometers, and it makes 2 turns. So I have this fancy ruler here that might help us a little bit. I'll use it just for a little bit so that we can get it nice and neat, so we get our drawing. First thing that I'm going to do is I'm just going to draw in a nice dotted line over here. This shows the direction of east. And it says that the plane turns or travels at 15 degrees. So we'll go, let's see, so 1, 2, 3, 4, 5, 6. We'll just make this 6 centimeters. So this is our first displacement right here. And we'll just call this one D1. And it said that it was 118 kilometers, and that this angle over here was 15 degrees. It then makes another turn, and this time it turns 35 degrees to the western side of north. So what I'll do here is I'll just use the ruler. Hopefully it'll slide over. Come on, ruler. And I'll just put in another dotted line this way so that I know where north is. Okay, so we need to turn this so that we've got 35 degrees to the west of north. And it was the same magnitude displacement, so I've got 1, 2, 3, 4, 5, 6. And we'll move this out of the way. And so this would now be our second displacement. So we'll call this one D2. And 118 kilometers. This angle right here is our 35 degrees. Okay, so then where is, and I'm not going to use the ruler anymore, where is the resultant for this? So let's pick a different color. So the resultant is right here. So this is what we're trying to find, this displacement. And I lied, I am going to use that ruler one more time, because now what I want to do is draw in our x and our y axis for this. So I'll draw in, there's my y axis, and we'll flip this around this way. We'll move it up over here, and this will be my x axis. Okay, so now I don't need this. So here's my y-axis, which is north, and here's my x-axis, which is east. So we have our blue displacement, and we also need this angle right over here. Now you can see it's pretty clear that we don't have two vectors that are perpendicular. D1 and D2 are not. So how do we find that? Well, we need to find the components of D1 and for D2. Because once we have those components, then what we can do is we can find the components of our resultant vector. So this arrow here that I'm drawing, the red one, that would be our x component. And then this arrow here that I'm drawing, this will be our y component. Okay, so let's do this. Let's take a look at our first vector. I'm just going to make another triangle over here. So just by sketching this out, roughly, we've got D1 was 118 kilometers. And if I make this into a right triangle, like this, and here's my 15 degrees, I now can find the components for this first displacement. Right, we can see that right here, going in this direction, this would be D1's x component, and then going downward here, this would be D1's y component. So what I'll do then is I'll use my trig functions to find out what those are equal to. So D1x, that's the adjacent side, will be equal to D1 times the cosine of my angle. So if I put the numbers in, I've got 118 kilometers times the cosine of our 15-degree angle, and this gives me 114 kilometers. We can do the same thing for the y component. The y component is the opposite side, so it will be D1 sine of our angle. So this will be 118 kilometers times the sine of our 15-degree angle. This gives me 30.5 kilometers. So now I have the two components for the first displacement. Let's do the same thing for our second displacement, D2. Well, this one goes in this direction, and I can make my triangle this way. Here's the right triangle. So this one was D2, and this was 118 kilometers as well. This over here was 35-degree angle. And now we can see for this one, we've got right here, this side, this is D2's x component. And then this side right here, this is D2's y component. So let's figure out what is D2x going to be equal to. So if I draw the triangle this way, that x component is opposite of this. So for this triangle, I'm going to use sine rather for the x component. So this would be D2 times the sine of our angle. So 118 kilometers times the sine of our 35-degree angle. And I have 67.7 kilometers. If we do the same thing for the y component, now we use the cosine function. So I have D2 cosine of my angle, 118 kilometers times the cosine of 35 degrees. This one gives me 96.7 kilometers. So now that I have the x and the y components for our two vectors, we just have to combine all the x components and all the y components. Now let's just be a little bit cautious about this. I'm going to use another color over here. If we take a look, we can see that our x component for D1 is in the positive direction, so I'm just going to make a note here. However, the y component for D1 is in the negative direction. The x component for the second D2 is going to be negative, but the y component is positive. So that's important because what we need to do now is we need to find the x and the y components for our resultant vector. So delta x would be equal to d1x plus d2x. So we have to combine these. So we've got our 114 kilometers plus our negative 67.7 kilometers, because that one is pointing downward. We have 46.3 kilometers for, that's a funny looking 3, 46.3 kilometers for our x component. Let's do the same thing for the y component. d1y plus d2y. Well, d1y is negative 30.5 kilometers plus our other component for d2y is 96.7 kilometers. And so this gives us 66.2 kilometers. So now I have my x and y components for the resultant. We can use our Pythagorean theorem. So d equals, it'll be delta x squared plus delta y squared. We take the square root, put the numbers in, we get 46.3 kilometers squared plus our 66.2 kilometers squared. Take the square root, and this gives us 80.8 kilometers. We're almost done. Now what we need to do is we need to figure out our angle. So we'll use our inverse tangent. And if we take a look over here to our original triangle, what I can do, remember with vectors, is I can move them anywhere. So this y component, the delta y, is really right here. This is the same as delta y. That's opposite of our angle. So when we put on our inverse tangent, it will be delta y over delta x. So we get our inverse tangent, and remember delta y is 66.2 kilometers divided by our 46.3 kilometers, and we have our angle of 55 degrees. So to put this all together, our final answer will be 80.8 kilometers at 55 degrees north of east. So that is quite a bit of work, but it's not something that we haven't done before. We're just using the trig functions that you already know how to use, and we're breaking down something that's very complicated looking over here into simpler right triangles. So that's how we do this practice problem. Give the others a try, and I will see you in class.